When you pick up your phone, it just works, right? You're on 5G, you're connected to your Wi-Fi, your headphones are streaming music over Bluetooth, all at the same time. It feels totally seamless, almost like magic. But behind that simplicity, it's an absolutely incredible feat of engineering. So today, we're going to pull back the curtain and explore how these modern wireless systems are actually built.
So that's really the big question, isn't it? How on earth does one single tiny device juggle so many different wireless signals at the same time? How does it keep them from all interfering with each other, while also somehow sipping just enough power to last you the whole day? Well, the answer comes down to this beautiful mix of physics, really clever hardware design, and a whole lot of software intelligence.
To really get our heads around this, I think it helps to think of all these systems as a core radio orchestra. See, each different technology is like its own instrument, playing a very specific part, but they all have to come together to create that final symphony of connectivity that you experience every day.
So let's meet the players in our orchestra. First up, you have cellular. That's your 4G and 5G, and its job is to connect you to the main mobile network for calls and data. Then, of course, you've got Wi-Fi, giving you that super fast connection at home or in a coffee shop. Bluetooth is the specialist for all your nearby gadgets, your watch, your earbuds. And finally, there's GNSS, which includes stuff like GPS. That's what handles your location. 4 totally different jobs, all happening in the same tiny box.
Okay, so we know what the systems are, but how do they actually physically work? This is where we get into the real puzzle for engineers, designing the unbelievably complex hardware that has to send and receive all of these different signals. Let's peel back that layer. Right at the heart of all this hardware is something called the RF front end. Now, if the radios are the instruments, you can think of the RF front end as the soundboard and mixing console for every single wireless signal. It's this whole chain of tiny components, amplifiers to boost the signal, filters to clean out the noise, and switches to direct all the traffic. It's the gatekeeper between the device's brain, the modem, and its ears and mouth, the antennas.
And that brings us to the antennas themselves. Now look, in modern wireless design, the antenna is not just some wire you stick on at the end. It is one of the single most critical and honestly one of the most difficult parts of the entire system to get right. It's everything.
And this slide just perfectly lays out the fundamental problem engineers are always trying to solve. On one hand, the goal is to have these incredibly powerful antennas that can handle dozens of frequency bands with perfect performance and no interference. But on the other hand, the constraint is that you have to cram all of that inside a sleek, sealed device with literally no extra space to spare. It's a constant battle between the laws of physics and modern industrial design.
But great hardware is only half the story. To make all those components really sing, you need this unseen engine humming along in the background. And that's the power and processing systems. They're basically the brains and the metabolism for the entire wireless operation.
Let's be real, raw radio waves flying through the air are messy. Signal processing is the digital brain that cleans it all up. It's what translates your digital data into radio waves to send out, and then translates incoming waves back into data you can use. It also has to filter out all the background noise from the environment, and it's constantly tweaking things to make sure their connection stays as fast and stable as possible.
And all of this processing has to be ridiculously efficient. Why? Well, just look at the scale we're talking about. When you have over 1 billion active devices out in the world, optimizing how much power they use isn't just a nice-to-have feature, it is an absolute, non-negotiable necessity. Every tiny drop of power you save adds up to a huge impact globally. And this is something you feel every single day. That efficient power management is the reason your device can stay connected all day without you having to run for a charger. It uses clever tricks, like adaptive power control, that tell the radio to use just enough energy to stay connected, and no more. It's this incredible balancing act between peak performance and all-day battery life.
So, we've looked at the orchestra of radios, the physical hardware, the processing brains behind it all. So what's the secret? What's the one thing that ties it all together and makes it perform so incredibly well? This is where we find the real key to the whole thing.
Let's go back to our orchestra. The RF hardware components, those are your instruments. The baseband processing, which is the chip handling all that complex signal work, well, that's the sheet music. It tells the instruments exactly what to play and when. But the real magic comes from the conductor, the device's operating system, which directs the whole performance in perfect harmony.
And that right there gets to the core idea. One of the major strengths of a company like Apple is this unbelievably tight integration between their hardware and their software. This means the teams designing the physical antennas are working side by side every day with the teams writing the code for the operating system.
And that is the ultimate takeaway here. The amazing performance you get from your device isn't because of one single magic component. It's because every single piece of the system, the RF front end, the antennas, the processing chip, the OS, is designed from day one to work together as a single cohesive unit. That's why your Wi-Fi call can seamlessly hand off to a cell tower when you leave your house. Integration is everything.
Now, of course, none of this is easy, not by a long shot. Building these systems is a constant, ongoing battle against the laws of physics and the demands of new technology. There are huge hurdles that these engineering teams have to overcome with every single new product they design. For instance, you have to manage interference. Wi-Fi and Bluetooth often use the exact same slice of airwaves, so the device has to be incredibly smart to keep them from shouting over each other. All this high-speed processing also creates heat, which you have to get rid of. And, like we saw, you have to cram all of this into a device that seems to get smaller and thinner every year. It's a relentless cycle of problem solving.
And that really leaves us with a final thought to chew on. As we move into the future, with new standards like Wi-Fi 7 and even more 5G bands becoming common, the complexity is just going to keep going up. So the big question becomes, what is the next great integration challenge that will define how we all stay connected? It's a puzzle that engineers are already hard at work trying to solve right now.